Welcome to Math, where problems are no problem. Picture five friends comparing how many texts they sent last night, trying to figure out who's the typical texter. You've probably heard the words mean, median, and mode thrown around in class like they're the same thing. They're not. There are three different ways of asking what's normal here, and each one answers it a little differently. By the end of this video, you'll see why one of these three numbers can get completely fooled by a single weird data point, while the other two just don't budge. Here's our five friends' text counts from last night. Friend 1 sent 2 texts. Friend 2 sent 4 texts. Friend 3 also sent 4 texts. Friend 4 sent 5 texts. And friend 5, who is clearly going through something, sent 60 texts. This whole list of numbers is called a data set, which is just a fancy word for the group of numbers we're working with. 5 numbers, 1 data set. The first way to find typical is the mean. This is the one most people just call the average. To find it, you add up every number in the data set, then divide by how many numbers there are. Let's do it. 2 plus 4 plus 4 plus 5 plus 60. That adds up to 75. Now divide that by 5, since we have 5 friends. 75 divided by 5 is 15. So the mean says the typical friend sent 15 texts. But look at our actual list. Nobody sent 15 texts. The closest anybody got was 5. Something's off, and we'll come back to that. The second way is the median, the middle value once you line every number up from smallest to largest. Let's sort our list. 2, then 4 again, then 5, then 60. With 5 numbers, there's exactly one number sitting dead in the middle, with 2 numbers on each side. That middle number is 4. The median is 4. Quick note for later. If you have an even number of values instead, there's no single middle one. So you take the 2 middle numbers and find their mean. But we've got 5 here, so we're fine. The third way is the mode, simply whichever number shows up the most often in your data set. Look through our list. 2 shows up once, 4 shows up twice, 5 shows up once, 60 shows up once. 4 wins. The mode is also 4. If nothing repeats, there's no mode at all. And if 2 numbers tie for most frequent, you can actually have 2 modes. But neither of those is happening here. So we've got 3 answers to what's typical. The mean says 15, but the median and the mode both say 4. Why such a big gap? It's that one friend who sent 60 texts. That single huge number drags the mean way up with it. Because the mean has to account for every value, including the extreme ones. The median doesn't care how big or small that number is, only where it falls in line, and it's stuck in the middle position no matter what. That one runaway number is called an outlier, a value way out of step with the rest of the group. That's the whole insight. The mean gets pulled around by outliers. But the median and mode hold steady. That's why when someone mentions average income or average home price, you'll often hear people ask for the median instead. A handful of billionaires or mansions can drag a mean sky high, but they can't do much to a median. Let's double-check we did each one right. Mean. The sum was 75. We had 5 friends, and 75 divided by 5 really is 15. Median. The sorted list was 2, then 4 again, then 5, then 60, and 4 sits exactly in the middle with 2 numbers on either side. Mode, 4 appeared twice while every other number appeared once. So 4 is the most frequent. All 3 check out. So, mean is the sum divided by the count, median is the middle of the sorted list, and mode is the most frequent value. And the real lesson is that a single extreme number can hijack the mean while leaving the median and mode untouched. If this helped, the next video covers how to measure how spread out your data really is. And if this channel's helping, sharing it with someone who's stuck on this helps more than you'd think.